When you say evaluating algebraic expressions, we simply look for what is the value of each algebraic expression, or to simplify each of the algebraic expression using the values given for each of the variables. As I have mentioned in the previous lessons, variables can take any values. So we could just assume the values for m, n, and p of the given exercise here. So we have five different algebraic expressions here. And then we are given that m should be 2, n is negative 1, and p is negative 3. For the given situation, we will be using these values for numbers 1, 2, 3, and 4, and 5. But of course, it doesn't mean that if we will meet again another m, another n, another p, m is still 2, n is still negative 1, and p is still negative 3. Just for this practice exercise, we will be using these values. When we go to another problem that may also use m, n, and p, it depends on the situation, uh, what would be the values of those variables. So let's now evaluate. When you say evaluate, it is actually similar to saying you substitute the values. Substitute means you are going to exchange the literal coefficients here into the given values in the said practice exercise. So for letter A, in number 1, we have 3m minus 2n. Right? So we give here, we now translate, and not necessarily, we now evaluate, sorry. So 3 is still 3, and then m will be changed into 2. Before placing 2 here, we need to be familiar to what do you call it? You need to understand that it's not 32. Huh? It will never be 32. 3m here, the operation separating 3m is multiplication. In short, we also need to make sure that as we substitute the value of m, which is 2, it also uses multiplication. My suggestion for everyone is when you evaluate, always use parentheses, regardless of whether it's multiplication or addition or any operation. Just for you to be guided that there are values which are negatives, just like what will happen here in n. Okay, so we will still use subtraction 2, and then n is negative 1. If you will not use parentheses here, you might saying minus 1, and you might interpret it as minus 1. Okay, that is why always use parentheses. So here is the first step for number 1. The first step again is substitution. The next step is now to operate. As you can see, we are already in algebra, but when you look at the process here, it still involves operations on integers. So integers, even fractions, if there are some later on, operations used on fractions will still be very important in algebra. So please review using the other videos. So 3 times 2 multiplication becomes 6. You still use the copy the subtraction. 2 times negative 1 is negative 2. Next here is we have a negative here. So you will use the double negative property, and the two negative signs will be changed into positive. In short, this will become 6 plus 2. And then operate. 6 plus 2 is simply 8. So this is the result for number 1 if m is 2 and n is negative 1. Again, the process involves substitution, operation, simplify, and then finally simplify if possible. Number 2, the operation separating m and then n, because they are written side by side, is still multiplication. So to evaluate this, we copy the negative sign, and then m, which is 2, n is negative 1, use the multiplication, and p is negative 3. And then get the product. Negative times 2, it will become negative 2, and then still you have negative 1, negative 3. Negative 2 times negative 1 becomes positive 2, and then times negative 3. By the way, if you could answer it directly, much better. But of course, I'm just using here the proper step-by-step process for you to be guided. And then finally, the answer here, 2 times negative 3 is negative 6. As you can see, we followed all necessary steps for us to get the given result. Number 3. In number 3, same, we will use m as 2 minus 2. P is negative 3. And since 3 is just a constant and there are no variables m, n, nor p here, simply just write here plus a 3. Again, that's the first step. Next step, operate. 5 times 2 is 10. Minus 2 times negative 3, negative 6. And then you have plus 3. Here, another double negative property is to be used. And then this will become 10 plus 6 plus 3. And simple addition will give us positive 19. So that's the result for number 3. Let's proceed with number 4. Number 4 now uses division. Okay? So just going to tell you first to substitute. So m becomes 2 plus 4 times n, which is negative 1, over 2 times p, which is negative 3. In this process, do not, I repeat, do not cancel this out, okay? Because this is separated by addition. What is the better thing you can do here is to simplify first the numerator and then simplify the denominator and simplify the whole expression later on. So let's start with the numerator. Numerator becomes 2 plus 4 times negative 1 rather is negative 4. And the denominator becomes negative 6. And then the numerator, 2 plus negative 4, basic addition of integers, you'll have negative 2 all over negative 6. Now that your numerator is just one term and your denominator is just one term, you can now simplify or divide if it's possible. So division of negative and negative will become positive. 2, 6, simplify it further, will result to 1 thirds. 1 third. So this is the result when m is 2, n is negative 1, and p is negative 3 for the expression m plus 4n all over 2p. Finally, for number 5 here, we will still use the values n as negative 1 times p squared. So negative 3 squared minus 8 times 2. Now, before we proceed with that, there is the notation here of squaring, as I have mentioned before, and it will be emphasized more better by the next lesson. When you say squared, I'm going to place it here. When you say negative 3 squared, it is not 3 times 2. Okay, we will say negative 6. It's not 3 plus 2. It's not negative 3 times 2. It means that we have two negative 3's multiplied to each other. Again, it's not 3 times 2 because 3 times 2 is 6, and you will say, my answer, sir, is negative 6 because I multiply this. This is incorrect. Exponentiation means there are two negative 3's multiplied to each other. Hence, negative 3 times negative 3 becomes positive. Positive what? 3 times 3, positive 9. So that is the process for exponentiation. So if it's cubed, means there are three different sets of it. If it's fourth, 4. Anyway, for this given, it's not negative 6, nor positive 6, nor negative 5, nor positive 1, nor negative 1, nor positive 5. it's just positive 9. So what the result here must be substituted on the other side. So you have negative 1 times 9 minus 8 times 2, which is 16. And then you have negative 1 times 9 is negative 9 minus 16. Here is again the process for integers. So if you still don't know how to do that, you may continue using the rule of successive alternate sign and transform this into plus negative 16. So that instead of looking at like this, you are just adding two negative numbers. So this will result to negative 9 plus negative 16. You have negative 25. So what is new to evaluating algebraic expressions? The answer is only the process of substitution. As you substitute them, the rest are just operations on real numbers that were discussed in the first grading. So again, the values of m, n, and p may take any other forms. And of course, you can also make your own expressions using m and n and p, and even you will use the same values and try for your improvement. Thank you very much. See you soon.